Hi, this is lesson 16. It's on equilibrium calculations or ICE problems, continuation from last lesson. It's originally posted on May 11th. That's the same day as the test, so probably a lot of you are seeing this afterwards. Just a reminder that the rest of this week, office hours, Zoom will be office hours. There is homework due on May 13th, 15th. The homework for this one will be due on Monday, May 18th. Okay. And it probably will be on Blackboard. All right, so last time we talked about ICE problems. And ICE problems stand for initial concentration, change in concentration, and then equilibrium concentration. Okay? And so if we have something like this, H2O2 going to form 2OH, and this is a reversible reaction, what we are talking about in number one here is relative changes. Right? So notice that H2O2 is increasing by plus X. Okay? So that means if I'm gaining reactants, I must be losing products. And now the stoichiometry is involved. For every 1 mole of H2O2, there's 2 moles of OH. So if there's X moles of H2O2, that means there must be 2X moles of OH. Okay? Or molarity of OH. All right, our second one, we're looking at equilibrium concentrations. We know this because it says it's at equilibrium. If it says at equilibrium, okay, these are my things and my concentrations, and I can plug these into K. All right, notice that this is OH squared over H2O2. Now, I should be honest, this is only if those are both gases. It doesn't say, but let's assume that they're both gases or both just aqueous. All right, so OH squared over H2O2. All right, and so I plug these in. That'll be 2 squared over 2.5. I do the math, and what do I get? I get 1.6. All right, so that is a review of last time. And then we went into looking at ICE problems. And now in ICE problems, we have to use an ICE chart, right? The ICE chart is initial, change, equilibrium. Okay? We start off with our reaction on the top, reactants going to products. Okay? Now, in the ICE charts, usually what we do is we start with our initial, then we find Q. Based on that, we can figure out the change, put those in, then the equilibrium, and then come back to K. So it's kind of like a snake. That's how we go through it. All right, last time we did simple problems. Go back, review. Now we're going to do some harder problems. Okay, now that simple problems we were talking about is all when Q and K are very close to each other, right? What that means, it's a small shift, right, between them, right? So if Q and K are really close, X is small, and therefore we can use this assumption. If Q and K are really different from each other, then it's a large shift, and that's when we have to use stuff like the quadratic equation that we'll go through today. Okay, so when is it small enough? Now, there aren't any actual rules, even though they'll say online, there's a rule for this. I'll tell you, typically, if they are both smaller, Q and K, both smaller than 0.01, that means it's usually a small shift. If Q and K are both larger than 100, typically it's a small shift. Not always, but typically. Now, in reality, what we always have to do is if we do that assumption, we have to, at the end, do and check for that 5% rule. Make sure that that assumption only causes less than 5% error. If it does, if it causes greater error, then we'd have to go ahead and not use the assumption, which really sucks. All right, let's go back and let's look at, or let's actually go on to an ICE problem. This is a hard one. Okay, so PCl5 gas goes to form PCl3 gas plus Cl2 gas. All right, so let's write this on the board and let's go through it. Do this every time. Now, the states are really important because the states tell me whether it's going to be involved in the Q or the K. These are all gases, so they're all going to be in Q or K. All right, so we're told that K equals 0.0211. Okay, and now when I have this, I go ahead and I do my ice. Okay, so what do I have initially? Well, I'm told that I have 2.5 moles of PCl5, and I place that into a 1.25 liter, container. So that means I have 2.5 over 1.25. That means I have 2 molar. Okay, my PCl3 and my Cl2, it doesn't say anything about those, so I have 0. Okay, now notice that it doesn't necessarily say, hey, initially I have 2.5. It just says I have it, right? Well, as long as it doesn't say it's the equilibrium, we have to assume that that's our initial case. All right, so we have 2 molar, 0, 0. Now we go ahead and we go with our Q. This is PCl3 times Cl2 over PCl5. Notice none of them have coefficients, so they're all just raised to the power of 1. I can plug in 0, 0 over 2, so that's going to give me 0. Now, a rule of thumb, if Q is ever 0, that means it's always going to shift towards the right, right? You can't get smaller than 0, so it can't shift to the left. But let's just think about that. Q's 0. K, even though it's small, is bigger than that. So it's going to shift from left to right. What that means is that I'm going to increase my products. So these are going to be plus x, minus x. Again, because these are 1, I only put plus 1x. 1 plus x, right? If this were 2 PCl3, this would be plus 2x. All right. That means at equilibrium, this will be 2 minus x. This will be 0 plus x, or just x. This will also be x. Okay? And now I can go ahead and I can plug in these into my K. Right? So this is my K. And now I need to go ahead and I need to say, all right, that means it's x squared over 2 minus x equals 0.0211. A lot of times people will forget to include the actual value for K. Because if you just have this, you don't actually have an equation, right? You need to have that other part of it, that other number. Okay, so now I can go ahead and I can do my work. Okay, now can I make an assumption? Well, Q and K. Q is smaller than 0.01, K is not. That means I can't use the assumption. Okay, I know these both look, oh, they're really small, but they're not small enough. Okay, Q and K, for the most part, must be smaller than 0.01. Okay, they're not, so that means I can't use the assumption. Okay, so that means I'm going to have to use what's called the quadratic equation. Okay, before we do this, let's go ahead and rearrange this. That's x squared. Oh, okay. Actually, what does that mean? The quadratic equation says if I can rearrange this equation here to look like this, then the value for x I can find as negative b plus or minus the square root of b squared minus 4ac over 2a. Okay. I'll put this on the screen later, and I'll also put it again. But this tells me if I put it in this, I can solve for x, right? This comes from just rearranging this to solve for x, but we don't have to do that, right? Because we have this equation. Okay, so let's go ahead and figure out what a, b, and c are. Okay, so I can rearrange this to be x squared equals 0.0211 times 2 minus x. Okay, this gives me x squared equals 0.0422 minus 0.0211x. All right, does that make sense? Yep. And now I can rearrange this once more to get all those onto the same side. So I get x squared plus 0.0211x. I forgot to turn off the sound of my computer. Minus 0.0422 equals 0, right? I have this in the same form as this, right? Where this 1 in front of it is A, this is B, and this value with the negative sign, that's my C. Okay, let's actually erase some stuff. In the actual solution videos, usually I do this on paper. That's what we got last time. And now we have all right, x equals negative b plus or minus b squared minus 4ac over 2a. I always just check to make sure it's the same as what the quadratic equation is. Because if I mess up here, if I make this plus 4ac, everything goes junky and I get pissed and yeah. All right, so this is negative 0.0211, right? Because that's my b. Right? My c is negative 0.0422. Okay, that negative is important. All right, so plus or minus, we'll talk about that plus or minus in a little bit, 0.0211 squared minus 4 times 1 times negative 0.0422 over 2 times a, so 2 times 1. That means that x equals, I did this beforehand and you'll see it on the paper, negative 0.0211 plus or minus the square root of, didn't do all of it, 0.00044521. I always like to just keep some extra digits. It's a little bit of a pain, but it is what it is. 4 times 0.0422 plus over 2. Okay, going through that, now I go ahead and I just say, all right, this equals negative 0.0211 plus or minus the square root of 0.1692 over 2. That's going to get me negative 0.0211 plus or minus 0.4114 over 2. Okay, let's talk about this plus or minus. Why is there a plus or minus? The plus or minus is there because of the mathematical fact that the square root of 4 could be 2, or it could be negative 2. Why? Because 2 times 2 equals 4. Negative 2 times negative 2 equals 4. So when I do square roots, right, the square root of 4 could be 2 or negative 2, right? So that means I have to include that negative plus or minus there in the quadratic. Okay, so now let's go ahead and solve. Okay, we're almost there. So we have, I can get rid of this, x equals negative 0.0211 plus or minus 0.4114 over 2. So what do I do now? I basically do both possibilities, right? One where Thanos snaps, one where he doesn't. All right, so if it's positive, or if it's negative. Okay, so notice this one is going to get me a negative value. Okay, these are my two possibilities. So which one, how do I know which one's right? I try them both. And it ends up that typically it becomes obvious which one's right. All right, so let's go ahead and say x is equal to 0.195 and x is equal to negative 0.216. Okay, if x were equal to 0.195, 2 minus that would be 1.805. Okay, this x would be 0.195, and this x would be 0.195. Let's say if x were equal to negative 0.216. So 2 minus a minus will give me 2.216. That would give this negative 0.216. And this is negative 0.216. Okay, so these are the two possibilities for my x and the two possibilities for the concentration. How do I know which one's right? I look at these and say, can I have a negative concentration? No. If I can't have a negative concentration, then this isn't right. Okay, so these are my concentrations. I'm going to end up, after doing this, with 1.805 molar PCl5, 0.195 molar PCl3, and 0.195 molar Cl2. Okay, those are my answers. And what do I do to make sure? Because I've done a lot of work and I don't know if I'm right. I can go ahead and I can just plug these back in for my K. I can say K equals 0.195 times 0.195 over 1.805. And that's going to get me 0.0211. Okay. Notice that's what I started off with. So I did everything right. Okay. There's one last thing I want to do with this is, remember I said then I can't make the assumption, right? Let's go ahead, and I'll do it actually on the screen, and I'll show what would have happened if I had used that assumption. Okay, so just to review on the screen, this is our first step. Our first step is always to make a nice chart. We start off with our initial, we find Q. Then after we find Q, we determine the shift. In this case, it's to the right from Q to K. Then we get our changes, then our equilibrium, and then we plug that into K, right? Once we have a K, then we can solve for X. In this case, X isn't small enough because Q and K aren't smaller than 0.01. Both smaller than 0.01. So that means I had to use the quadratic equation, which first thing was rearrange, okay? Then plug it into my quadratic. Okay? I do a lot of work. It's kind of a pain, and I get my 2 answers. Okay? Once I have those 2 answers, I go ahead and I plug them back in. Okay? So I had x equals 0.195 or negative 0.216. Here are my 2 things. This is impossible. So we get it. Okay? All right, and then I check my work. In this case, it was 0.0211, so that means it was good. Okay? All right, by the way, notice how we said the assumption wasn't good enough, right? If we had used the assumption, we would have said that 2 minus x was just equal to 2, okay? So what we would have gotten was 2. In reality, what we got was 1.085. So how far off is this? Well, I take the difference between those two, which is 0.195. I divide by the 2, and I get that the assumption would have been 9.75%. So the assumption would not work, okay? So that's why I had to do the long way, okay? Remember, we don't necessarily have to do this. All we need to do is make sure Q and K are both small before we actually say, hey, can I do that assumption? In this case, we could. Okay, so that is a hard way. You can see, I hope, why we like to make the assumption, okay? We like to make the assumption if x is small, right? Because quadratic is tougher, okay? Now, there's one last thing on the quadratic rule is that there's what's called the square root trick. Sometimes when you're doing these problems, it looks like you need to use a quadratic, right? Let's say I had 2a going to b plus c, k is equal to 2, okay? That means that my k is equal to b over c over b times c over a squared, okay? I'm not going to do the ICE table, but what I would get if I started off with 5 molar was x times x over 5x squared, okay? Or x squared over 5 minus x squared. Well, notice how I could just take the square root of this side, and that would get me x over 5 minus x equal to 1.41. I could then rearrange it, and I could solve for x conventionally without having to use the quadratic equation. You have to use the quadratic equation anytime you have x squared and x, okay? If you only have x terms, then you don't have to use it. All right, so that is it for a hard problem, okay? So you're going to do video problem 16a, and I want you to do this 2 ways, okay? I want you to use the assumption on this one, and I want you to use the quadratic equation. We'll go through both of those in the video problem. I'll do it on the piece of paper, show both steps, right? So this is a review from last time, but also looking at quadratic equation. You should get the same answer, right? So I'm going to show, hey, if you can use the assumption, you get the same answer. But, right, sometimes you can't use it, and that's when you have to do the hard problem. So we just went through the quadratic formula. Let's move on to another type of problem where we have not just reactants or products, but we have a mix of the two. All right, so this is the third type of problem we'll do. Remember, there are some on the video solution, there are some on the homework, that all these different ways, and even on the extra problems. The setup's always the same, an ICE table to figure it out. Okay, so let's do this problem. We have H2 gas plus I2 gas going to 2HI gas, and we're told K equals 5,020. Notice that's a big K. So what that means is this reaction goes very far to the right. Okay, it's one that actually isn't very close to being equal amounts to each other. You get a lot of HI, very little reactant. Okay, so we have 2.5 moles of I2, 2.5 moles HI. We mix them into a 1.25 liter flask. Remember, we need to work in molarity. So I take that 2.5 for the I2, divide by the 1.25, and I get 2 molar. That's for my I2. For my HI, I also have 2 molar. And then notice it doesn't mention H2, so it's 0 here. Okay, so my Q is going to be HI squared over H2 times I2. The 2 there means this is squared. Okay, so when I do this, I can plug in, I have 2 squared over 0 times 2. That's going to get me something that's undefined, or we've called this infinity. What that means, it's all the way to the right, right? If I have 0 of one of the reactants, that means it's all the way to the right. Okay, so infinity versus 5,000, which one's bigger? Infinity, right? So Q is infinity, K is 5,020, right? So it's going to have to shift towards the left. So if it shifts towards the left, that means these increase, products decrease, okay? This is 1x, 1x, 2x. All right, so now I go on. I have x here, 2 plus x, and then I have 2 minus 2x. All right, so that's what I do. Start with the initial, find my Q, determine the shift, find my change, get equilibrium in terms of x, and now I plug it back in. So K equals 2 minus 2x squared over x times 2 plus x. All right, so now I need to go ahead and I need to say K equals 2 minus 2x squared over x times 2 plus x. Okay, so, and this equals 5,020. Okay, so now we need to think, can we do an assumption? Right? Can we assume that x is small? Well, let's look at our Q. Our Q is infinity, our K is 5,020. Are both these larger than 1,000? Yes. So therefore, actually, what did I, sorry, give me 1 second. Are they both larger than 100? Yes, and therefore we can do the assumption. Oops, sorry. All right, we can do the assumption. Okay, so I'm going to assume x is small. All right, now I have x's in 3 different places. What do I assume it's small? Okay, here's the thing. When I say x is small, what I should actually say is assume x is small in comparison to numbers. Okay? What that means is anytime I have a number minus x or plus x, I get rid of it. Okay? But this x by itself, I can't get rid of. So I'm going to assume 2 minus 2x is just equal to, and 2 plus x is equal to 2. Why? Because if I'm subtracting off 2x and I say that's small, then this also will be small. Okay? So that's going to get me 2 squared over x times 2 equals 5,020. Or 4 equals 5,020 times 2x. Actually, I can just say, well, x equals 4 over 2 times 5,000. Okay. So what's that going to give me? That's going to get me a small number. That's going to get me 0.00039. Okay. All right, so now I have this. Now I can go ahead and I can put it back in. Now remember, at the end, we're going to check our work with finding x or k, but we're also going to check these two assumptions. Okay, so give ourselves some room. So this is x. This is 2 plus x. And this is 2 minus 2x at equilibrium. All right. The nice thing about using the assumption is we only get one value, unlike when we use quadratic. So we had said x equal to 0.000398. Okay? So what that means is that here, 0.000398. 2 plus this would be 2.000398. And this right here would be 2 minus 2 times 0.000398, or 1.999. Okay, now, significant figures still matter. Notice those numbers at the top, 2.50, 3 sig figs. 2.50, 3. 1.25, 3 sig figs. So I'm going to write all these with 3 sig figs. So I have 0.000398, or 3.98 times 10 to the minus 4 molar H2. Okay, either number is fine. I just like to use the sig figs once I get that small, or the scientific once I get that small. This with 3 sig figs would just be 2.00 molar I2. And this to 3 sig figs would also be 2.00 molar HI. Okay. I start off with 2 molar, and I'm ending up with 2 molar. That's because it shifts so small that it doesn't even affect it once I look at the sig fig. Okay. All right, let's check our work. So K equals HI squared. So that's 2 squared times this value, and then times this. Okay. That's going to get me 4 divided by 3.98 e to the 4 minus divided by 2. That gets me 5,025. Okay. That is very close to what I started with. So this is valid. Okay. So that means I probably did everything right. And let's just check our assumption. So what was our percent off? Well, remember what our assumption was. Our assumption was 2 plus x was equal to 2. And 2 minus 2x was equal to 2. Well, instead, we get something very close. I'm going to check with this one. Why? Because this is a bigger difference than just adding it. Okay, so what did I do? I did actually, let's go with assumption. I assumed it was 2. In reality, it ended up being 1.999. And it ended up being 1.999. This is my actual. Okay, times 100%. So this ends up being 0.05% off, which is definitely valid, right? So, and notice it was even a small enough change that in the end it didn't even matter. Okay, let's just show this on the screen. All right, so here is what we do. We go through our steps. Remember, once we find Q, we compare it to K, and in this case, our Q is big, our K is big, so that means it shifts towards the left because Q is bigger than K. But also, because they're both greater than 100, we can assume that it is a small shift. Okay, we plug it in and we get our answers. Okay, this should actually be 3.98 times 10 to the 4th instead of 4 times 10 to the minus 4. All right, that is it. These are the same number. All right, so that is it for that problem. Here we have that check at the end, and we said it was valid. Okay, now let me just go through on the screen one more example. So in this last one, we said that it's 2 squared, or actually go back one. We said 2 squared over x times 2, right? That's because we start off with 2 and 2, right? Let's say, and I'm not going to go through all the steps, let's say instead of starting with 2 molar, we started with 4 molar, okay? Well, what I would get is 4 squared over x divided by 4, or 4 over x equals 5,020, right? I just did all the ICE table behind the scenes. If I were to rearrange this, I would get that x is equal to 7.97 times 10 to the minus 4. Okay? That means at equilibrium, I would have 8 times 10 to the minus 4 for my H2, and I2 and HI would be 4 mole. Okay? Both of these cases are at equilibrium. Same reaction can have 2 different equilibriums depending on the concentration. Okay? So it's not like every time I have these 3 things, I'm going to get the exact same concentration. What's important is the ratio, that K constant, is going to be constant if these are at equilibrium. Right? If I plug in both of these values, I'm going to get the same. All right, so let's have you guys do a problem. This video problem 16b. And we're going to use the exact same reactions, exact same K. And what I want you to do is figure it out if we have 0.2 molar H2, 0.3 molar I2, and then 2 molar HI. Okay? I'm going to give you a tip. You will not be able to use the assumption. Okay? You're going to have to figure out what it is. You're going to have to use the quadratic formula. Okay? But we're going to go ahead and show that on the video problem 16b. Right? If you're having issues with video problem 16a or 16b, do it, try your best, then watch the video and take it step by step and make sure you understand each one. Okay? Because I can do these ICE problems. The whole goal of the videos is for you to be able to. All right. So that is it for equilibrium calculations. Last time we did simple. This time we did harder ones involving quadratic formula. And then also what happens if we have a mixture of reactants and products. Okay? Here are some videos. I'll post these online on how to use ICE tables, how to use the quadratic, and then also the assumption. Okay? Next time we're going to continue on a little bit on equilibrium and kind of tie it into what we talked about at the very beginning, thermodynamics. And then we're going to move on to acids and bases, which is loads of fun. Okay, So other than that, remember homework number 16 for this lesson is due via Blackboard on Monday, May 18th. All right. Have a good day.